Think about where mathematics comes from. It is easy to picture equations scribbled on a chalkboard or a professor lecturing in a university hall, but the reality is much dirtier. Long before humanity built cities or studied the stars, we faced a much more immediate problem: basic survival. And to survive, early humans had to know how to keep count. Imagine you are living thousands of years ago in a small agricultural settlement right along the banks of the Saraswati River. You own a herd of cattle. Every morning, your herd goes out into the dense, predator-filled forests to graze. Every evening, they return. You don't have words for numbers. You don't have written symbols. So how do you ensure that a calf hasn't wandered off during the day? Early humans solved this puzzle using an ingenious concept known as one-to-one correspondence. Here is how it worked. For every single cow that left the settlement in the morning, the herder would drop a single physical pebble into a clay pot. At dusk, the process is reversed. As each cow returns to the enclosure, one pebble is removed. If the pot is empty at the end of the day, the entire herd is safe. If any pebbles remain, you know you have missing cattle. This simple act of matching one physical object to another was the birth of the natural numbers: 1, 2, 3, and so on. It took the abstract idea of counting and made it a physical, tangible reality. Pebbles in a pot work perfectly for tracking a herd over a single day. But if you need to track biological or celestial cycles over weeks and months, carrying around hundreds of loose stones becomes impossible. To find the earliest archaeological evidence of humanity solving this long-term problem, we have to look to the Lubumbo Mountains in Africa, over 35,000 years ago. Here, researchers discovered the Lubumbo bone, featuring 29 deliberately carved notches. Anthropologists believe it functioned as a lunar phase counter, or menstrual calendar. By carving these notches, humans moved from mirroring physical objects in real time to recording data as abstract, permanent symbols. Fast forward to roughly 20,000 BCE, near the headwaters of the Nile River in the Democratic Republic of Congo, and we find the next major evolution, the Ishango bone. This artifact stands out because it is not a continuous sequence of scratches. It organizes its tallies into 3 distinct columns. Looking closely at this specific column, we can see the notches are grouped exactly into sets of 11, 13, 17, and 19. Those are the prime numbers between 10 and 20. And another column on the same bone seems to demonstrate the concept of multiplication by doubling. The creators of the Ishango bone were demonstrating that a number is an abstract concept that can be manipulated and grouped, proving this level of mathematical thought is tens of thousands of years old. As small settlements expanded into urban centers, the math had to scale up. By the time of the ancient Indus Valley civilization, cities like Harappa and Lothal were engaging in widespread international commerce. A merchant trading with Mesopotamia could not simply carve a notch into a bone for every single item they loaded onto a ship. They were moving high-value commodities in massive bulk, things like cotton, terracotta pottery, and heavy chunks of unpolished lapis lazuli. To track this level of wealth, ancient merchants replaced simple tallies with a robust system of standardized weights and complex written accounting. While merchants tracked physical goods in the markets, Indian philosophers during the Vedic period were looking inward, pondering quantities far larger than any trader could ever hold in a ship. The ancient Vedas gave specific names to powers of 10, reaching all the way up to 10 to the 12th power. Later Buddhist texts, like the Lalitavastara, extended this theoretical naming system up to 10 to the 53rd power. This cultural focus on expressing quantities in powers of 10 set the stage for the development of place values and the Indian numeral system. It provided the structural framework that directly created the base 10 number system. The numbers powering our modern spreadsheets and calculators represent an unbroken chain of human problem solving, beginning with a single pebble dropped in a clay pot and evolving into the engines of modern civilization.